Hello all, good morning. Welcome to Unacademy. Let's crack it. Now this crack GATE and ESE with India's largest online platform. Here, before going to start this, let me introduce myself. Myself Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Now here we can see the Unacademy's learning app. How to install the Unacademy's learning app here. Now, what you will get in an academy? So, you will get the daily live classes, chat with your educator, engage in discussion, ask your doubts and answer the polls all while the class is going on. Now, live test and quizzes, evaluate your preparation with our regular mock test and quizzes and get the detailed analysis on your performance. Now, structured courses, you will get all our courses are structured in a line with the exam syllabus to help you the best prepare for it. And unlimited access is also provided to you. One subscription gets you the access to all our live and recorded courses to watch from the comfort of any of your devices. Now, iconic subscriptions. So most benefit part of this iconic subscription is here personal coach. You will get the personal coach in the iconic subscription. Then in this you will get one-on-one guidance from the top exam experts as your personal coach. Align your preparation strategy and learning resources. Now mains question and answer practice is given to you. Strengthen your mains answer writing through the regular practice with the evaluation and personalized feedback. Now study tracker you will get here. Participate in a study tracker plan and study booster workshops. Evaluate your progress in bi-weekly reviews with the personal coach. Now all benefits of plus you will get live classes from the top educators, mock test and quizzes, structured batches courses in the line exam with the exam syllabus. Okay. Now you will get a plus subscription here. So you will get plus subscription. So daily live classes you will get in this, live test and quizzes, structured courses, unlimited access also you will get. Now learn with the top educators of India, India's most learning platform, that is Unacademy. So you can learn with this top educators. So you will get your study in the next level with the help of these top educators. Now, so these are some of the top educators of Unacademy. Now, here you will get the different courses for GATE and ESE. There are many live courses are available for each and every branch of engineering. So, mechanical engineering, electrical engineering, ECE, CSN, IT, civil engineering, general aptitude, instrumentation engineering. So, you will get all the branches here, and every courses is available. Now, these are some highlighted parts of the plus subscription. India's best educators you will get, interactive live classes you will get, then structured courses and PDFs you will get, live test and quizzes also you will get. So you can select the plus subscription. So you will get all these benefits. So most important thing here, iconic subscription. So all the plus benefits are included in the iconic subscription, as well as the important benefits of here you will get in iconic subscription, it is personal coach. Each student will have a personal coach to clear your doubts. Then personalized test analysis. So whatever your preparation is done, so you can analyze with the help of personalized test analysis. Then study planner is also there. Then preparatory study material is also there. No. Plus plan. So if you go for the 12 months plus subscription plan, so it will cost you the 30,250. I will suggest go for at least 12 months subscription plan, so that your study will be completed or your course will be totally covered in this 12 months plan subscription. And if you use my promo code DSP, then you will get a 10% discount on your subscription plan. So it will cost you 27,225 only. Okay. Now iconic subscription, so you can get the iconic subscription also. If you get the 12-month subscription plan, that is for 50,250, then it will cost you 50,250 for the 12-month subscription plan. And the 12-month subscription plan, if you use my promo code DSP, then you will cost it only 45,225, right? Here, evolve for the GATE 2022. The new batches are started already here for the batch C for civil engineering. Here already started from the 25th of January. So you can enroll your name as today also. So you will get a 10% discount if you use my promo code DSP while enrolling your name. Now here assign for GATE 2023. The batch is already started for the civil engineering. Now new batch alert is there. So batch C started from the 25th of January. So you can use my promo code DSP to get the 10% discount on your subscription fees. So ultimately you will get it here, all the courses available for the civil engineering GATE 2023 already. You will start your preparation from right now to get the top rank. Okay, now you are evolve gate 2022. So to get this, this is for the chemical engineering. So many code educators are available here to guide you. So enroll your name today only, and you can use my promo code DSP to get the 10% discount on your subscription fees. Now my batch C for mechanical engineering gate 2023 is also already started. So you can enroll your name here uh, with the Unacademy's platform. You can take any subscription plan, plus or iconic subscriptions to take your study on the higher level. So enroll your name today only. Okay, now we'll start our actual topic here. Okay, now see, this is in this lesson or in this lecture, we will study the most important question which is asked in your question paper from the last year GATE exam, right? So you can solve it here. I will try to solve most of the questions which is asked in your GATE exam question paper, previous year's GATE exam question paper, so that it will help you to study your accordingly, okay, for this GATE 2021. Right, so just we are revising all the questions, already preparation is done here. So now, here consider a likely applicability of Cauchy's integral theorem to evaluate the following integrate counterclockwise around the unit circle C. So I is equal to here close integral over C sec z dz. Z being a complex variable, the value of I will be here I is equal to 0 or singularity is equal to phi. I is equal to 0, singularity set is equal to plus or minus 2n plus 2 upon 2 pi, where n is varying from 0, 1, 2, 3 and so on, and I is equal to pi by 2, singularity set is equal to plus or minus n pi, where n is equal to 0, 1, 2, 3 and so on. So we can find out the poles at the point. The poles are at z0 is equal to n plus 1 by 2 pi is equal to minus 3 pi by 2 minus pi by 2 pi by 2 and 3 pi by 2 and so on. None of these poles inside the unit circle, right? No, none of this pole lies inside the unit circle, because it is a unit circle, it means radius 1. So definitely these poles are lies outside the circle C. These poles lies inside the unit circle, inside the unit circle. So therefore singularity set is 5, and I is equal to 2 pi I, where some of the residues of f of z at the poles is equal to 2 pi I into 0, which is equal to 0, right? So you will get the correct option is I is equal to 0 with the set 5, right? Now this is for 2 marks question asked in civil engineering, chemical engineering GATE 2005, right? Now, Cauchy's integral theorem, the value of the integral integration being taken in a counterclockwise direction, closed integral over C z cube minus 6 upon 3z minus I dz is. So we will use here Cauchy's integral theorem. Okay, so Cauchy's integral theorem, so you can Cauchy's integral formula, because if we use the theorem it will only for the lies outside the circle C, right? So here f of z is equal to what? So we will get Cauchy's integral formula f of z upon z minus a dz is equal to 2 pi I into f of a. This is your Cauchy's integral formula. Okay, so whether we will check first of all this z is equal to a lies inside the curve C or not. Okay, this is applicable only when it is lies inside the curve C. So we can see it here. If we can write here f of a. So here closed integral over C z cube minus 6 upon 3z minus I dz. So instead of this, can I write 1 upon 3 is equal to 1 by 3, take common, close integral over C. So 3 taken common. So z cube minus 6 upon z minus I by 3. Okay. Z cube minus 6 upon z minus I by 3. By applying Cauchy's integral theorem, by applying Cauchy's integral theorem using f of z is equal to z cube minus 6. So which is equal to 1 by 3 into 2 pi I into I by 3 minus is equal to 1 by 3 into 2 pi I into I by 3 bracket cube minus 6. Right? So you will get 1 by 3 into 2 pi I by 3 pi I by f of I by 3. Right? But f of z, it means what? This I z cube minus 6. So 2 pi I by 3, so 2 pi into I cube by 27 minus 6. So which is equal to 2 pi I raised to 3 and this I. So I raised to 4 upon here 26 minus this 4 pi I. Okay, minus 4 pi I upon 81, 27 3s are minus 4 pi I. So which is equal to 2 pi upon 81 minus 4 pi I. Okay, so we'll get option A. Right, A is the correct option. The value of the contour integral over z mod of z minus I is equal to 2. 1 upon z square plus 4 dz is a positive sense is. Okay, so it's a positive sense is. So first of all we will find out the points, whether the points lies inside the curve C or not. So we'll see. 1 upon z square plus 4 is equal to 1 upon z plus 2i into z minus 2i. Right? So 0, 2 lies inside the circle. Mod of z minus I is equal to 2. While pole 0 minus 2 lies outside the circle. Right? Outside the circle. Mod z of z minus I is equal to 2. Right? So we can find out the residue. So 2 pi I by Cauchy's residue theorem, integral over C, f of z dz is equal to 2 pi I into sum of the residues. Right? So residue which lies inside the curve C is residue at the poles which lies inside the curve C. Residue at the poles which lies inside C. Right? Which is equal to 2 pi I into residue of f of 2i. So which is equal to 2 pi I into 1 upon 2i plus 2i is equal to pi by 2. 4 pi I pi by 2. So the correct option is here pi by 2, D. D is the correct option. Now in a complex number z is equal to root 3 by 2 plus I 1 by 2, then z raised to 4 is. So it is z raised to 4. So we'll calculate here. Z is equal to given root 3 by 2 plus I 1 by 2. So root 3 by 2 it means what? Cos pi by 6 plus I sin pi by 6, which is equal to e raised to I pi by 6. So z raised to 4 it means e raised to I 4 pi by 6, which is equal to e raised to I 2 pi by 3. So e raised to I 2 pi by 3 it means what? Cos 2 pi by 3 plus e raised to I theta cos theta plus I sin theta sin 2 pi by 3. So cos 2 pi by 3 the value is minus 1 by 2 and sin 2 pi by 3 is root 3 by 2. So minus 1 by 2 plus I root 3 by 2. I root 3 by 2. So option is B, but it's square. So correct option is B. Okay. So let z is equal to root of minus 1. So here instead of I is given z. Z is equal to root of minus 1. Then one value of z raised to z is. So what is the one value of z raised to z? So we can calculate here y is equal to, we can take y is equal to z raised to z, right? So y is equal to here e raised to I pi by 2 or j pi by 2. Instead of I we can write j pi by 2 raised to z, right? So log of y is equal to log of e raised to j pi by taking log on both sides. So you will get log y is equal to j log e raised to j pi by 2, which is equal to j into j pi by 2, which is equal to log y is equal to z square is minus 1, so minus pi by 2. So y is equal to e raised to minus pi by 2. Okay, y is equal to e raised to minus pi by 2. So y it means what? Z raised to z. So here is option e raised to minus j pi by 2. So e raised to minus pi by 2. Minus pi by 2, option D. Okay. For the function sin z upon z cube of a complex variable z, the point z is equal to 0 is a pole of order 3, a pole of order 2. It's a very simple example. This is a, now see, directly you can say that it is a pole of order 3 many times, but this is wrong. So you thought it's a very simple question, but it is wrong because you have to expand sin s in terms of z, right? So sin z series f of x is equal to here sin z upon z cube. So 1 upon z cube as it is sin z, it means alternate z minus z cube by 3 factorial plus z raised to 5 by 5 factorial minus z raised to 7 by 7 factorial plus and so on, which is equal to 1 upon z cube minus z square minus 1 upon 3 factorial plus z square upon 5 factorial minus and so on. Therefore function f of x has the pole of order 2. Okay, so has the pole of order 2, is a pole of order 2. Okay. Now, the value of the integral over c dz upon 1 plus z square, where c is the counter, mod of z minus I by 2 is equal to 1 is. So, mod of z minus I by 2 is equal to 1 is. So, what will be the value of this mod of z minus I by 2? So, 1 plus z square, it means z square is equal to minus 1. So, z is equal to plus or minus 1, right? So close integral over z 1 z square plus 1, which is equal to 1 upon z minus I and z plus I, right? The poles at z is poles at I and minus I are 0 1 and 0 minus 1, right? So you will get 0 1 and 0 minus 1. So mod of z minus I by 2 is equal to 1. So we can check the whether which poles lies inside the curve C, right? So x plus iy minus I by 2, which is equal to 1. So it is a circle with radius 1. So here x minus 0, right? Plus I into y minus 1 by 2. So here 0 minus 0 1 by 2 is the. So definitely this lies inside the curve C. 0 minus 1 by 2. So this is 0 minus 1 by 2. And obviously it lies the curve C, right? So will mod of z minus I by 2 is equal to 1. So we see that 0 minus 1, that is minus I lies outside the curve C. So 1 by 2 is light, but 0 minus 1, because this is a circle with center at 0 1 by 2 and radius 1, right? So obviously 0 1 lies inside the curve C, and while pole 0 minus 1 lies outside the curve C. Okay, so therefore I is equal to, you can get the residue of integral 2 pi I into residue at f of I, which is equal to 2 pi I into 1 upon 1 minus I and 1 plus I. So I minus I and I plus I, which is equal to I minus I is cancel out. So you will get which is equal to pi. Simple pole, na? So I is equal to pi. Yes, option B. Clear? Now, if the semicircular counter D of radius 2 is as shown in the figure, then value of the integral over C 1 upon s square minus 1 ds is. So immediately value of the integral s square minus 1. Okay. So limit as z, you will get 2 pi j closed integral over C 1 upon s square minus 1 ds is equal to closed integral s minus 1 into s plus 1 ds. So which is equal to 2 pi j into sum of the residues. Poles s is equal to minus 1 is not inside the counter, right? Counter D, but ds is equal to 1. But s is equal to 1 lies inside D. So residue at poles s is equal to 1 is. So limit z is equal to limit as s tends to 1. So s minus 1 into f of z is 1 upon s minus 1 into s plus 1, which is equal to, so put s is equal to 1, that is 1 by 2. So close integral over C 2 pi j into 1 by 2. So 2 to cancel out, so pi j. Yes, j pi. So option A. Okay. Now next. Potential function phi is equal to x square minus y square. What will be the stream function psi with the condition psi is equal to 0 at x is equal to y is equal to 0? Okay, at x is equal to y is equal to 0. So what will be the potential function for this? So you will get here dabba phi by dabba x is equal to dabba psi by dabba y, which is equal to 2x is equal to dabba psi by dabba y. So psi is equal to 2x plus y plus c. So psi at 0, 0 is equal to 0 plus c, 0. So psi is equal to 2xy. So A option. Now, a complex variable z is equal to x plus z comma 0.1 has its real part x varying in the range minus infinity to infinity. Which one of the following is the locus shown in the lines of 1 by z in the complex plane? Okay, so we will see z is equal to x plus 0.1 j, right? So z inverse is equal to 1 upon x plus z 0.1, which is equal to x minus 0.1 upon x square plus 0.1 square, right? So which is equal to x upon x square plus 0.1 square minus 0.1 upon x square plus 0.1 square, which is equal to u plus iv. So which implies u is equal to x upon x square plus 0.1 bracket square. Okay. V is equal to minus 0.1 upon x square plus 0.1 bracket square. So from this equation 1 and equation 2. So from 1 and 2, we'll get u square plus v square is equal to x square plus 0.1 square upon x square plus 0.1 square is equal to 1 upon x square plus 0.1 square. Right? which implies u square plus v square is equal to 0.1 upon x square plus 0.1 square to 10, right? Using equation 2, we'll get here u square plus v square minus 10v. U square plus v square plus 10v is equal to 0. So u square plus v plus 5 bracket square is equal to 25. Right. So required locus you will get 0 minus 5. Right. So this is your u, this is your iv. Right. So we will get correct option is the locus. We have to find out the locus. Okay. Now next is the value of the expression minus 5 plus I10 upon 3 plus 4i is the value of the expression. So we will find out the value of the expression is plus 10i upon 3 plus 4i. So rationalize 3 minus 4i upon 3 minus 4i. Minus 5 into 3 minus 15 minus minus plus 20i plus 30i plus 40. I square is minus 1. So we will get here minus 15 upon here a square minus b square 9 a square plus b square here you will get, so 9 plus 16, right? 40 minus 15 25 plus 50i upon 25 1 plus 2i. The integral f of z dz evaluated around the unit circle on the complex plane for f of z is equal to cos z upon z is, okay. Has a simple pole at z is equal to 0 and z is equal to 0 is inside unit circle on complex plane. Therefore, residue of f of z at z is equal to 0. Its integral over c f of z dz is equal to 2 pi I into residue at z is equal to 0, which is equal to 2 pi I 1, which is equal to 2 pi I, right? Option A. Very simple actually. Now, the residue of the function f of z at z is equal to 2 is. So, at z is equal to 2, we will calculate the residue. This is a pole of order 2. So, we will use the formula residue at f of z at z is equal to 2 is. So, residue at f of a is equal to 1 upon n minus 1 factorial into e raised to n minus 1 upon dz raised to n minus 1 into f of z, z minus a bracket raised to n. So z minus a bracket raised to n into f of z at z is equal to 2 we have to find out. Otherwise we will take it in the next slide. So residue of f of n equal to 1 upon n minus 1 factorial into d raised to n upon dz raised to n minus 1 into z minus a bracket raised to n into f of z, z is equal to 2. Here n is equal to 2, whole of order 2 and a is equal to 2. Therefore residue at f of 2 is equal to 1 upon 1 factorial a upon dz into z minus 2 bracket square into f of z at z is equal to 2. Okay, so z minus z dz, so you will get here f of z is 1 upon 1 factor 1 d by dz of z minus 2 bracket square into f of z is 1 upon z plus 2 bracket square into z minus 2 bracket square. Z is equal to 2. Right? Get it here. At z is equal to 2. So minus 2 upon z plus 2 bracket cube is equal to minus 1 by 32. The product of complex numbers 3 minus 2i and 3 plus 4i results in, right? Twelve I minus 6i plus 6i, z is equal to 17 plus 6. If z is equal to x plus zy and x and y are real, the value of mod of e raised to iz is, the value of mod of e raised to iz is f is equal to e raised to iz is equal to cos z plus I sin z, right? Cos z plus I sin z, which is equal to cos of x plus zy plus z into sin of x plus iy, which is equal to cos x into cos zy minus sin x into sin iy plus z into sin cos iy plus cos into sin iy. Okay? So we know that sin I theta is equal to I sin h theta, cos I theta is equal to cos h theta. So f is equal to, you will get cos x into cos hy minus z into sin x into sin hy, right? Plus z into sin x into cos hy minus cos x into sin hy, which is equal to cos x into cos hy minus sin hy plus z into sin of x into cos hy minus sin hy. Cos hy minus sin hy is equal to cos hy minus sin hy is equal to e raised to minus y is equal to e raised to minus y. So you will get f is equal to here e raised to minus y into cos x plus j sin x. Okay. And mod of f is equal to e raised to minus y into 1, because cos square x plus sin square x is 1, right? So which is equal to e raised to minus, the correct option. Either you can do in this way, or the alternate solution is also available. So directly you can calculate mod of e raised to iz, which is equal to zz, e raised to j into x plus iy. This is actually very simple. You can use the alternate method, whatever is suitable for you. Jx minus y. Right? E raised to minus j bar minus y. So e raised to jx into mod of e raised to minus 1. So e raised to jx is equal to 1, where x is real. Mod of e raised to jx is equal to 1, x is real, and 1 into mod of e raised to minus y. So you will get e raised to minus y. Right? The correct option is D. Here, D is the correct option. Now, the value of integral over z sin z upon z, where the counter integration is a simple closed curve around the origin, is counter integration is simple closed curve around the origin. So this is simple closed curve, as we know that just now previously we have seen. So here's f of z is equal to what? Sin z upon z, right? So 1 upon z into bracket z minus z cube by 3 factorial plus z raised to 5 by 5 factorial plus and so on. So you will get it here 1 minus z square by 3 plus z raised to 4 by 5 and so on. Okay, so no poles lies inside the or the given curve. So integral over c. So all the poles are outside the closed C, because it is at around the origin. So definitely, as it lies outside the curve C, so by Cauchy's integral theorem, sin z upon z dz is equal to 0. Option is A. Right? Now next. An analytic function of a complex variable z is equal to x plus iy is expressed as f of z is equal to u of xy plus iv of xy, where I is equal to root of minus 1. If u is equal to xy, the expression for v should be, okay, so you can see as it is analytic function. So f of z is equal to u plus iv. Right? So it must be Vux by CR equations, Cauchy's Riemann equation. So you will get Ux is equal to Vy and Uy is equal to minus Vx. Right? Or this is equation 1, this is equation number 2. So here U is equal to given xy. Right? So you will get Ux and Uy. So Ux is equal to what? Y. And Uy is equal to what? X. Right? So just put this value in this equation 1 and 2. So you will get Vy is equal to y, right? Vy is equal to y because Ux is y, and Vx is equal to minus x, right? Call this as equation number 3 and equation number 4. Now integrating equation 3 and 4, we can now get V as Vy is equal to y. So which implies dabba V by dabba y is equal to y. So separating the variable, dabba v is equal to integral of y dy. So v is equal to derivative integration cancel out. So v is equal to y square by 2 plus f of x. This is equation number 5. From 5 we have vx is equal to f dash of x. because y square by 2 is constant, right? Or this is equation number 6. Now from 4 we have, from 4 Vx is equal to minus x, right? So f dash of x is equal to minus x here, right? So f dash of x is minus x, which implies dabba f by dabba x is equal to minus x, right? So integral of dabba f is equal to integral of minus x dx, right? Integral of dabba x is equal to integral of minus x dx. So you will get here f is equal to minus x square by 2 plus k. Now substitute this value of 5 in k. So we will get v is equal to y square by 2 minus x square by 2 plus k. And v is equal to y square minus x square by 2 plus k. Correct option is here C. Now the value of the integral over C cos 2 pi z upon 2z minus 1 z minus 3 dz, where C is the closed curve given by mod z is equal to 1 is. So you will get integral over C of z is equal to here. The curve which lies inside the curve C and which not lies inside the curve C, we are taken in the f of z. So here I is equal to, we can write integral over C cos of 2 pi z upon 2z minus 1 into z minus 3 dz, which is equal to 1 by 2 close integral over C cos of 2 pi z upon z minus 3 upon 2z minus 1 or z minus 1 by 2, because 2 already taken outside, right? So z is equal to 1 by 2 lies within the mod of z is equal to 1. So definitely it will lies inside the curve C. So z is equal to 1 by 2 lies inside C, because C is the circle with center as 0, 0 and radius 1, right? So we will get I is equal to here, by Cauchy's integral formula, you will get I is equal to 1 by 2 into f of 1 by 2, right? So f of z is equal to cos of 2 pi z upon z minus 3. So f of z is analytic all these points. So I is equal to 1 by 2 into cos of 2 pi, z is 1 by 2. Cos pi is, you will get cos 2 pi, cancel out. So cos pi upon 1 by 2 minus 3. So 1 by 2 minus 3. So after simplifying, you will get 2 pi I. 2 is, right? So 2 pi I by 5. So it is 5 by 2. 1 by 2 minus 3 by 2 is 5 by 2. So you will get cos pi is minus 1 and minus 5 by 2 is 2 by 5, right? Plus, so 2 pi I by 5 in C. The analytic function f of z is equal to z minus 1 upon z square plus 1 has the singularities at the simple singularity z square plus 1 is equal to 0 minus 1. So z is equal to plus or minus 1. So at singularity at z square is equal to minus 1, z is equal to plus or minus I, you will get minus 1. So only plus 1, then plus or minus. So I and minus L. Option D. If f of z is equal to C0 plus C1 z inverse, then closed integral over unit circle 1 plus f of z upon z dz is given by, right? So you will get f of z is equal to C0 plus C1 z inverse the closed integral 1 plus f of z upon z dz is equal to, you have to find out. Okay. So 2 pi I which is equal to 2 pi I into residue of f of z at z is equal to 0. Right here nothing is there, z minus a. So z is equal to 0. So residue z is simple. So 2 pi I to bracket 1 plus f of 0. Right? So 1 plus f of 0. So f of z is equal to what? C0 plus C1 z in 1. F of 0 is equal to 0. C0. So 2 pi I into 1 plus f of 0. F of 0 is C0. So 2 pi I or z. 1 plus C0. D is the correct option. Okay. So next. If f of x plus iy, f of x plus iy, here x cube, where I is equal to root of minus 1, and f of x plus iy is an analytic function, then phi of x plus iy is your phi of x plus iy. Okay. So we can calculate here d by u by d by x. F of x z is analytic, then it satisfies the CR equation. So d by u by d by y is equal to minus d by v by d by x. Right? So u is given. U is x cube minus 3xy square. U plus iv, na? Z is equal to u plus iv. So comparing with this, u is equal to this. Calculate d by u by d by y. Minus 6xy. Right? D by u by d by x. So what is the equation 2? Equation 3. So minus 6xy and calculate which is equal to minus d by v by d by x, because d by u by d by y is equal to this. So this. Since f dash of z is equal to what? D by u by d by x plus I d by v by d by x. So ux plus idx. Using equation 2 and 3 we can write f dash of z is equal to 3x square minus y square plus I 6xy. By Millen-Thomson method, put x is equal to z and y is equal to 0 by Millen-Thomson method. So you will get in terms of z only. F dash of z is equal to 3z square y 0, this 0. So f of z is equal to integrating. So integral of f dash of z is f of z into z cube by 3. Right? So you will get 3 cancel out. Of z is equal to z cube. But z is equal to what? X plus iy. A cube plus 3a square b. A cube minus, you will get 3a square b minus 3y square plus I into 3x square y minus y cube. So ultimately you will get 3x square y minus y cube. So option B. Okay. Now counter C. in the adjoining figure is described by. So we will see the adjoining figure here. Counter C in the adjoining figure is described by 0 P Z plane Y. Okay. 0 Z plane Y. Now, counter C in the adjoining figure is described by, we will calculate here. Put that J is equal to root of minus 1. X square plus y square is equal to 16. It means it is a circle with center at 0, 0 and radius 4. Right? So your integral over C 1.5 Z is equal to 2 pi I into f of x. Pi I into, it will get 2 into 3z square plus 16. So 2 pi z minus 18 plus 6 minus 4 is the correct. Now see, the modulus of the complex number is, it's a very simple question. Modulus, just we want to first of all simplify it. Okay. So z is equal to given 3 plus 4i upon 1 minus 2i, so into 1 plus 2i upon 1 plus 2i, 3 plus 6i plus 4i minus 8 upon 1 minus plus 4 minus 5 plus 10i upon 5 is equal to minus 1 plus 2i. So mod of z is equal to root of minus 1. Mod of z is equal to root of minus 5. The residues of a complex function. So we will calculate the residue at z is equal to 0. Option B. Okay, residue at z is equal to 0. So what's the formula? F of z, z minus a. So z minus 0 into f of z. 1 minus 2z upon z into z minus 1 into z minus 2 at limit as z tends to 0. So at z is equal to 0. This z cancel out. Z is equal to 0. 0 minus 1 minus 1 and minus 2 plus 2. So 1 by 2. The residue at z is equal to 1. So z minus 1 into 1 minus 2z upon z into z minus 1 into z minus 2 at z is equal to 1. So 1 minus 2 minus 1, 1 minus 2 minus 1 and 1. Minus 1 upon minus 1, 1. Residue at z is equal to 2, which is equal to limit as z tends to z minus 2 into 1 of minus 2z upon z minus 1 into z minus 2 at z is equal to 2. 1 minus 4 minus 3 upon 1 minus 3 upon z, na? Z by 3 by 2. Right? So this is your residue at z is equal to, so the respectively 1 by 2, 1 minus 3 by 2. 1 by 2 1 minus 3 by 2. So option C. Okay. Now next. The counter integral over e raised to 1 by z dz, which has the counterclockwise unit circle in the z plane, is equal to. So counterclockwise unit circle in the z plane is equal to, so e raised to 1 by z. So e raised to 1 by z, we can expand it. E raised to 1 by z, e raised to 1 by z, it means 1 plus integral of 1 plus 1 by z plus 1 upon 2 factorial into z square plus and so on. dz. So obviously z is equal to 0. So z is equal to 0. This is residue at z is equal to 1 plus z inverse and so on. So you'll get residue at z is equal to 1. So integral over c e raised to 1 by z dz is equal to 2 pi I into residue at, sorry, z is equal to 0. Z minus 0 is z. No? Residue at z is equal to 0 is 2 pi I into e raised to z, 1 by z. So 1 by e raised to, we'll get here is 1 by I. But I is equal to root of minus 1. So C. Okay. The value of z square upon z raised to 4 minus 1 by uses Cauchy's integral formula around the z plus 1 is equal to mod of z plus 1 is equal to, where z is equal to x plus iy. I said mod of z plus 1 is equal to, we can calculate z square, z raised to 4 minus 1 is equal to 0, z square minus 1 raised to square is equal to 0, z square plus 1 into z square minus 1. Z square is equal to minus 1, z square is equal to 1, z is equal to plus or minus I, z is equal to plus or minus. Okay. So by Cauchy's residue theorem, you will get sum of the residues at pole. So residue at z is equal to minus 1 lies inside the curve C. Okay, z is equal to minus 1 lies inside the curve C. Plus and minus I lies outside the curve C. So we will get the residue at z is equal to minus 1. So here residue we will calculate. Residue at z is equal to minus 1. Right, we can see this is circle with center at minus 1 0. Obviously there is I minus I. So the lies inside the curve C only minus 1. 1 is here. Only one point is lies inside the curve C. Because mod of z plus 1 is equal to 1. Na? Mod of z plus 1 is equal to 1. Z is equal to x plus I by x minus 1 comma y plus 0. So minus 1 0 is the center. So only the points lies inside the curve C are minus 1. Plus I minus I lies outside. Now z is equal to minus 1 lies inside the curve C. So residue at z is equal to minus 1 is f of z, limit as z tends to 1 minus 1. So f of z minus 1, it means z plus 1 into f of z, z square upon. So we can write z plus 1, z minus 1, z plus I, z minus I. Right? Plus 1 cancel. Z is equal to minus 1. So minus 1 and minus 1, minus 2. Z plus minus 1 minus 1 minus 2 and here z is equal to minus 1. So 1 plus I, 1 minus I square minus 1. So 1, 1. So minus 1 by 4. Yeah, that is minus 1 by 4. So 2 pi I into minus 1 by 4. It means minus pi I. Pi I minus 1 by 4. minus pi I by 2 b. Okay, that's it. So we'll solve almost 27 questions on which is asked in your question paper accordingly. Okay, so thank you so much for listening my lecture, and please do like, share and subscribe if you like it, and do not forget to hit the bell icon for notifications. Okay, thank you so much. I will be here tomorrow with the same thing, complex analysis, with the next question.